Hello! So today I will be showing you how to assemble your automatic thrust testing device. So you will need the parts shown on the table here. You will need to 3D print all of these parts, which are available on printables.com and will be linked in the description. You will also need an Arduino Uno or clone, a micro SD card reader. This one is from HiLetGo. Also will be linked. This is an ADC converter, or a analog digital converter, that is used with the load cell. This is a 10 kilogram load cell. You will also need a 16 by 2 LCD display. You will need a push button switch, which is just a single throw switch. I have installed wiring connectors here. I believe these are JST connectors. These are these will make it a little bit easier to work with. You will also need at least the male end or female end of a servo connector. You will also need a 4-channel 3.5 millimeter jack and a 4-channel 3.5 millimeter female jack. These parts are Printables parts as well. These are part of Space Dust Studios' C-clamp design, and we will be utilizing those for securing the mount. So I will begin with the circuit board. So not seen here is the Arduino Proto Shield, because I have it pre-assembled right here. So I will not be going through the assembly instructions because, as you can see, mine is already assembled and I do not have a spare to go through it with. These connectors here are just typical circuit board connectors. Actually, this came with the Proto Shield and I repurposed them. You don't necessarily need to use them, however they do make connection a little bit easier. The buttons and LEDs on here were just part of the Proto Shield and are not necessary to this design. I simply went ahead and installed them as part of the Proto Shield. I will be attaching a circuit or a pin connection diagram to this video so that you can see exactly how you should wire this up. It's rather simple though. So we are going to move out all the electronic parts. We're going to begin by moving aside some of these pieces here. And we're going to take the primary housing body. We need to install heat set inserts into the housing body. For installing these heat set inserts, you are going to need a soldering iron. This is a TS100. You're going to begin by simply inserting the heat set inserts into the holes here. We will then just slowly press them in. You want to get them just flush with the surface. Alright, there we go. That is installed. Now, I'm going to give you a close-up of the circuit board. Of course, again, I will be including wiring diagrams available on printables.com for this. You will also, of course, need some wire to make these connections. Alright, so we're going to begin by installing the Arduino. Now, of course, you want to make sure that you've cleared out all of your support material before beginning this, unlike what I did here. Okay, so once you have support material sufficiently cleaned out, you're going to install your Arduino. It's going to go right here on these support pins with the USB and power port sticking out. You're going to take your pan head screws here, or flush head screws. So you will not be using this one, at least on my Arduino. I cannot fit the nut into this spot, so I will only be using these 3 holes to support it, which is sufficient. I like to begin with this far back one right here. It goes through. You'll want to grab a nut. Make a point of using these nylon nuts so as to not be conductive. So what I like to do is try to stick it back there, get it onto the nut, and then grab a screwdriver. And while holding the nut in place, you want to try to screw it into it. And we got it. Alright, so we're actually already pretty secure. So we're going to continue with this screw hole. Now I'm going to just leave it at these 2 screws, as the 2 screws are sufficient to hold the Arduino in place. Now, we're not going to use that yet. We will be using our LCD display. So, on the back of the LCD display here, we have these 4 pins. I have already bent these a little bit out. So when you first get them, you will want to gently, very gently, put your finger under them and pull them until they hit about a 45-degree angle. That will allow you the wiggle room you need to fit it. Just be careful you do not break these pins. So the LCD goes in like this with the pins on the right. They sit against these 4 holes. Grab nylon screws. I recommend nylon screws, however you don't have to use nylon for this. You will want to use nylon nuts, however. Now again, getting the nut onto the screw hole can be a little bit tricky. Once you get it on, just hold it with your finger and begin screwing it in. And we will continue with the other 4 screws. Okay, our LCD is assembled now. Just want to make sure everything is nice and tight. At least hand tight is important. All right. We're going to insert our micro SD. The SD card reader fits into this spot right here. It will be slid into place and held in by friction. So you want to set it like that, very loose. Then you will just press this into place. It does not require a lot of force, so do not force it. And then pop it in, and it should sit there with lots of security. Okay, now we will begin with the circuit board for the Proto Shield. Make sure you remember the orientation of this. On the bottom we have this 6-pin female lead, and in the Arduino we have the 6-pin here. So you want to align these. and make sure all of your pins go in, and then gently press down on both the back and the front sides, ensuring it is fully secured. Now, you want to take your servo connector, which, if you notice, does not have the power supply attached. We do not want to be powering our Arduino off of the ESC. This will ensure that we have consistent power and we don't have this parasitic drain coming from the Arduino. However, it will require you to power the Arduino either from USB or from the native power port. So, we're going to insert the power port like so, with the signal wire facing toward the back. It goes into this slot here. It will just slide right in. So I will use my thumb to apply some pressure, and you can see it sticks well, and then we will just continue sliding it into place. This may require a slight bit of force, but do not use excessive force. Okay, good. Now we will take this piece, which is our servo lead clip. This is going to slide right over this area. So you want to slide it over the pin, or the lead, onto these plastic grips here. And it will secure your servo connection very nicely. Now you want to take the LCD plug here, which will be this 4-prong female plug, and plug into the LCD. Be sure all 4 pins are plugged in. And it slides on just like that. Now we will grab this, which is our 6-pin SD card reader pin, and attach to the SD card reader, ensuring all pins are firmly inserted. As so. Now, you want to take your 3.5mm female jack, which should have your ADC wired to the end of it, and you want to move the servo leads out of the way, as well as the LCD leads, and remove the fastener nut. Place it through the hole on the right hand side here, you can see, and then secure it with the nut. Does not need to be more than hand tight. Great. Now we will take our push button switch, the JST plug, push it, well, remove the nut and washer from it. Insert it through the hole. Add the washer and the nut. And then secure the push button with the nut and the washer. It's probably a good idea to ensure that the nut ends up with one of its flat faces facing the back side as opposed to a point. Great. Now, put the ADC securely into the housing and connect your JST plug to connect your switch to the Proto Shield. And we are fully wired up. Great. So I did not discuss these two holes here because I will not be using them for this build. Inside the housing, there are 4mm nut-sized holes opposite these holes that allows you to securely mount with 4mm screws to the housing, so you can secure it to any sort of plate that you may want, including the optional mounting attachments that are provided on principles for this kit. So now we're going to go ahead and close up the housing. So this is our housing back. We have these two vertical supports that will keep the housing from flexing when the button is pressed. As you can see, it's rather flexible. There is an orientation to this, so the side with a larger gap from the edge between these two supports is the bottom. You can also see in the arrangement of holes here. So it will slide on just like that. And then we will pick up these small M3 flush mount screws. Again, no more than hand tight. And voila, our housing. So you can see the SD card here. Easily accessible, easily insertable, removable, very convenient. Try not to drop your SD card into the housing, that is not convenient. Your servo pins here, also convenient. Remember that the signal is on the back side. I may add markers to this housing prior to publication for your convenience. Now we will set that aside and we will begin on the testing stand. So you will need this, which is your clip-mounted testing bracket. This, which is your pillar. You will need your load cell, which has been pre-wired here with the 3.5mm 4-channel adapter. You will also need your large motor mount, the calibration platform, and 2 C-clamps courtesy of Space Dust Studios. To begin, we're going to, please disregard the surface finish on this. We are going to take the 4mm nuts and insert them into these holes as shown. Then we're going to take 4mm screws and insert them into the closest screw holes into the middle. There we go. Now your direction does not really matter here. However, your motor will be facing toward the flat side, and these protrusions will be facing toward the outside edge of whatever table you will be mounting to. So I will actually be reversing this and mounting it like so. Now you will want to make sure this is nice and tight. But again, do not pass hand tightness or you may crack your plastic. And this will be mounted as so. Now, with the pillar assembled, you are going to take your load cell and assemble it into calibration configuration. So you want your arrow to be pointing down, like so. You're going to take M4 screws. Now, if you have M by 25, M4 by 25, you can go in through the top of this bracket here and secure it with nuts. However, I only have M by 20, so I will be going from the bottom with these holes still being big enough to fit. So you want to secure your load cell, again, ensuring your arrow would face down in this setup. Now securely fasten it, making sure that it is not over tightened. Your load cell will look like this. Ensure that your arrow is pointing down. Now you will take your large motor bracket with the flat side facing toward the top and slide it onto the load cell. Now you want to get your holes here aligned, and then you're going to take your M4 screws and secure your motor mount to the load cell. Securing the rear side with nuts is optional, but always recommended. And this will be your calibration setup. Now finally, you're going to take the calibration plate. This is optional. It will mount like so onto the large motor bracket and provide you a nice large plate with which to use calibration weights or whatever you may have available, as including printed center lines to assist you in getting center of gravity correct. I'm going to secure these with 2 M3 screws. Now, you don't have to truly secure this with nuts and everything. This is just going to sit on top of here temporarily while we use it to calibrate the load cell. As you can see, if I were to use longer screws, we could have secured it. However, it's, as I said, unnecessary. And that is our calibration setup. Finally, you take your C-clamps. The C-clamps attach to your table mounting bracket, like so. Just slide them on. They have a very nice, satisfying slide on. And we are good to mount this to the edge of a table and begin testing. So to calibrate, we're going to upload the calibration script to the Arduino. You can see it has been plugged in to the computer. We're going to go to the Arduino IDE and hit upload. Once uploading is complete, make sure you open your serial monitor and you should be greeted with the calibration message. It informs you to remove all weight from this scale, and that is what our current setup is. It will be taired to compensate for the weight of our calibration platform. We're going to press enter. The scale has been taired, and now it asks us to use weight. So for this example, I'm going to use a set of calibration weights. You can purchase these from Amazon or several sources online. You can see this is a 500 gram calibration weight. We also have 200 gram, 100 gram, and several others. I recommend using a calibration weight similar to what you expect your thrust to be, your maximum thrust to be. So I expect my maximum thrust will be around 500 grams, possibly a bit more, but I think 500 grams will be enough. Otherwise, you can go look for a cheap kitchen scale and try to find an object around your house with a nice amount of mass and use the scale's reading weight to generate your accuracy for this test setup. So we're going to now add 500 grams weight. Make sure you use your center lines on the calibration plate to center the mass, center of gravity. It's very important. We go back to our serial monitor, enter in 500 grams, and it tells us what our calibration factor is. So you want to write that down. You should use a different calibration factor than my own. Each load cell will be slightly different. That will vary depending on temperature and humidity. So do not just copy this number. So now we return to our building setup where we will begin disassembling the calibration set. Gently pull your clamps off to allow for easier work. Disconnect the load cell from your Arduino and set that aside. Now we want to remove the calibration plate. This will just be in reverse order from our assembly. Remove the motor stand or the motor mount from your load cell. We will need to reverse its direction. Now we're going to assemble the load cell with the mount here into the pillar. So go ahead and pre-screw in these M4 screws, the same ones we used to secure it to our clamp mount base earlier. At least for a tractor configuration, you will want your propeller to be on the side of the flat front. So in that situation, the force will be going this way to the right, and you want your arrow pointing in that direction. However, if you're in a pusher configuration, you will want to reverse it. As in, a pusher will be pushing the air that way, pushing the motor this way. But again, for tractor, we want the arrow facing toward the flat side of this pillar. Get this nice and tight, but no tighter than what hand tight is capable of. You do not want to crack your pillar here. Great. Now we're going to mount our motor bracket here, again with the flat side on the same facing same direction. Make sure your holes line up. It doesn't necessarily matter which direction your screws go in, but I like to have the flush face on the side with the propeller. Secure with nuts, optionally. This is not required. Alright, and now we can attach our motor. So each motor will mount differently. This motor mount is designed to support several sizes here, all with M3 screws. So in this specific situation, I actually don't have screws that are the correct size. They happen to be about 2 millimeters too long, so I will be using a nut to add as a spacer. You do not need to secure your motor with all 4 screws, however it is advisable. You do need to use at least 2 screws. I will be using 2 screws here for brevity. And there we go. So let's hook a propeller up to this and get it remounted to the table and run a test. So now we're going to exit out of the calibration script. We're going to go to our primary script, the auto thrust tester. Now we go find our calibration factor, which is right here, and we are going to enter in 204, and I'm going to use 0.2. So, to go over some of these factors, we have the SPI speed of the SD card in millihertz. So I'm using 2. My SD card is not very good. You may be able to use a faster megahertz speed. The sample milliseconds, I'm using 1 sample every quarter second. You can change this. Sometimes the ADC will limit you to doing no less than 200 here, a sample every 5th second. However, some use cases may desire slower sample rates, so sample every half second or even second. So these are our pins, which are of course in the pin diagram. Now we have these factors here, so auto test. If this is defined, we will enable the automatic testing of an ESC. If this is commented out, it will be fully manual. And what I mean by automated testing is that our servo port here will be active and will enable us to automatically control and cycle the ESC from low to max and back to low, holding at the maximum throttle for a period of time. The time at max throttle is here, 3 seconds. Our parameter here, minimum test force, being 50. That is saying that we require 50 grams of force to be read on the load cell in order to determine that the ESC is indeed active and under our control. If 50 grams of thrust is not detected, the Arduino will revert to manual control mode only. So we're going to go ahead and upload this to our Arduino. Now we have our motor and stand set up in the test configuration. It has been mounted to the table using the C-clamps again. The motor is wired up to the ESC. We will be powering our ESC with a 12-volt power supply, benchtop power supply. And for demonstration purposes, I will be using a servo controller and demonstrating the manual mode configuration first before demonstrating the automatic mode. So let's turn on our Arduino. And we are ready to test. Test starting. It's going to be checking the servo, offering us the ability to skip. Let's not skip it and wait for it to complete. Did not find the servo, so we are ready for input. Now you can see it's showing the force as well as the max force. Let's turn on the ESC. Our ESC should now be active, and we can begin the test. Now, I did not want to reach maximum speed because I do not have protective equipment and my face is quite near this motor, so I allowed it to reach 114 grams, and it seems to have done that quite nicely. Give you a close-up of the display as it ticks. And then we can just press the button and the test is complete, and it will show us where the file has been saved to, and it begins ready to test again. So for this test, we will be demonstrating the automatic mode. Our benchtop power supply has been set to 8 volts at 4 amps, which should prevent the motor speed from getting too high. You can see our servo lead, our ESC, has been plugged into the Arduino. We will now only need to press the button to begin the test. So the Arduino will check the motor by trying to ramp to half speed and seeing if any force is visible on the load cell. It only requires 50 grams to pass the test. The ESC has been found, and now it will begin the sweep. The test is done. We can conclude it with a press of the button.